Okay, our first two problems on the study guide use either leopard and lower sums or midpoint method to approximate the area under the curve. If you recall, the first thing I want to do is establish what delta x should be. I'm going to be using Excel to do this. So to find delta x, we're going to take the length of the intervals. We're going from 2 to 4, which is an interval length of 2 spaces, and divide by the number of rectangles, 10. So a point 2 is what delta x is. So I'm going to go to my keyboard or my computer over here, and I'm going to enter for delta x 0.2. And I've already set all these columns up to go 4 decimal places. I did that by selecting the entire area here. I right click in the selection area, go to Format Cells, choose Number, give it 4 decimal places. I didn't specify in this problem how many decimal places to go, but 4 is a good place to go. I'm going to scroll this all the way down. With upper and lower sums, you want to have exactly one more than the number of rectangles per boxes here. So you can see I've got 11. If you look up in the corner there, right in this area up here, and when I select, it will say 11 rows. So you want to make sure you have 11 rows there. The first x is whatever the beginning of the interval is, so that's x equals 2. So I put a 2 here. And I want to go up by delta x, so equals, I have to hit the equal sign. And I select this, and I put plus 0.2 because that's what delta x is. And then I just scroll that all the way down to the bottom, and I should be ending at 4. So starts at 2, ends at 4. I can verify that x is exactly as it should be. For the y entry, I want to put the square root of x squared plus 5. X is what's in this column here. So when I type it in my computer, I'm going to put equals square root sqrt is square root parentheses. And x is this number here, so I'm going to click this so it chooses A2. Caret 2 is squared plus 5 in parentheses. That's how you type in the square root of x squared plus 5. Hit enter. And if I drag this all the way down, it's going to keep on changing that. So you can see up here, square root of A2 squared plus 5, square root of A3 squared plus 5, square root of A4 squared plus 5, and so on. And then for the area is always equal to y times delta x. So B2 times C2 goes there. And if I click here and drag this down all the way, it's B3 times C3, B4 times C4, B5 times C5, and so on. These are the areas, these are the numbers that I care about. The upper sum equals and lower sum equals is what I'm going to put here. Make that a little bit bigger font so we can see. And then here I'm going to put equals sum, and I want to add up the upper sums. So I want to add up the 10 biggest ones. So the biggest ones start here and go to there. And then equals sum parentheses. And the smallest 10 are going to be these 10, not including 0.9165 in parentheses. Let me make those bigger also so we can see them. Okay, so the upper sum is 7.6748, the lower sum is 7.3583. So the approximate area, we need to average those two answers. So if I do equals average of these two numbers, or you can just do 1 plus the other divided by 2, take your pick. 7.5166. I would want you to print this out, but you're welcome to do it by calculator also and get all the same information. But the upper sum is equal to 7.6748. Lower sum is equal to 7.3583. And the area is 7.5166. That's what I look for on that one. Number 2, same type of problem. This time though it says midpoint method to approximate. I'm going to clear all this stuff out. So again, for you, start a new sheet, hit plus, and then you start a new sheet. I'm just going to clear this stuff out so I can use the same structure. Midpoint method requires one less box here, so I can just delete this row at the bottom. Alright, so we still have x, y, delta x, and area as my categories up here. Once again, it says use 10 rectangles. So again, with midpoint method, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to use exactly 10 rectangles. And we're going from x equals 1 to x equals 4. So again, delta x is my first priority. From 1 to 4 is 3 spaces. We're doing 10 rectangles, so point 3 is delta x. Our first x is going to be the starting point 1 plus 1/2 of delta x. So 1.15 is what we're going to end up with right there. So I'll start with that. I'm going to go ahead and put 1.15 in this box. 1.15 is slightly larger than the bottom. And I'm going to go up, so I'm going to equals this, and I'm going to add delta x, which is 0.3. And if I keep on adding 0.3 all the way down, you'll notice we end up at 3.85, slightly below 4. If I want one more, now it's above 4. We don't want to go above. So we always want to be between. So I'm starting at 1.15, ending at 3.85, and just do it like that. There we go. dx is 0.3 all the way down. Even though we did weird stuff to find x, dx is what it is. Whatever this is right here is what dx is. Y equals 2 over x plus 1. So 2 or equals 2 divided by, and if I want to divide by x plus 1, parentheses, and instead of typing x, I want to select the x value in that row, plus 1 in parentheses. And then I'm going to just drag that formula down, and the areas are going to still equal B2 times C2 for the first one. So this times this gets me the area, and if I drag that formula down, it does B3 times C3, B4 times C4, B5 times C5, and so on. These are the area with the 10 rectangles I care about. And I would put area equals, and then equals sum parentheses, and then I would just drag all that right there, in parentheses, equals, and 1.1830 is the right answer. So feel free to use Excel. If you want to use the calculator and you're not comfortable with Excel, just talk to me about it, and I will go through that with you also individually if you need the help. Moving on from there, everything else is going to be done with either area formulas or integral formulas. Evaluating by interpreting in terms of area means that we're going to actually graph this equation on this interval. 4 minus half x is a line equation. To graph a line, I simply need 2 points. The 2 points I'm going to pick are x equals 2 and 4 because those are the numbers I have right there. If I replace x with 2, half of 2 is 1, 4 minus 1 is 3. Half of 4 is 2, 4 minus 2 is 2. 1, 2, 1, 2, 3, and 1, 2, 3, 4, 1, 2 are my points. Connect the dots. There's the graph, the part of the graph I care about. And if I draw my line straight down, the answer to this integral is simply the area of that trapezoid. To find the area of the trapezoid, I simply have to find the two bases, which this base is 2, this base is 3, and the height is the distance between the bases, which is 2. So area of a trapezoid is 1/2 times the height times the sum of the bases. 3 and 2 add up to 5. Half of 2 is 1 times 5 is 5, so the answer to that problem is 5. Number 4. 2 plus the square root of 4 minus x squared from 0 to 2. So, I know that y equals 2 plus the square root of 4 minus x squared. I know that y minus 2 therefore equals the square root of 4 minus x squared, which means that y minus 2, the quantity squared, is equal to 4 minus x squared, which means that x squared plus y minus 2 squared equals 4 is the equation of the circle created by that equation. A circle with a center of 0, positive 2, 0 of course, and then change the sign, positive 2, and a radius of 2. And since this is plus the square root of 4 minus x squared, it's only the top half of the circle. So if I'm at 0, 2, and I got a radius of 2, I go left 2, up 2, right 2, I would get this semicircle right here. That's what that equation gets me. But then my interval goes only from 0 to 2, so the only part of the circle I care about starts here and ends here. So 0 to 2, that's all I care about. So all this over here doesn't count. So throw that out. So all I'm looking at here is the right corner of this circle. That's all I care about. If it said -2 to 2, now I got the whole half a circle. So again, depending on this interval, that's how that comes into play here. The circle is just the top half, so I'm not going to come back down here. It's just going to be from here to there. And then if I go straight down, like so, what we're looking at is actually a square, rectangle, it doesn't matter, but square or rectangle, and then a semicircle. Alright, not even a semicircle, but a quarter circle. So, the area of the region that we're trying to find, the area underneath the curve, which is right here, all this stuff is going to be the rectangle, or square in this case, 2 times 2, plus the quarter circle, 1/4 of pi times the radius squared. Radius being 2, 2 squared is 4. So if I multiply it out and add it up, 2 times 2 is 4, 1/4 of 4 pi is going to be pi, 4 plus pi is the answer. 7.1416. If you wanted to approximate it, I'd prefer 4 plus pi. Number 5, we have an absolute value expression, and if I take 2x minus 4 equal to 0, 2x equals 4, so x equals 2. 2 lies on the interval, so I do have to worry about that. So, graphing an absolute value equation, all I care about are the endpoints and any place that the structure equals 0. If I put 0 in for x, 0 minus 4 is -4, make it positive. Put in 3, 6 minus 4 is 2, make it positive. Put in 2, 4 minus 4 is 0, doesn't matter if it's positive or negative. 0, 4 is right here. 3, 2 is right here, and 2, 0 is right there. And we connect the dots. So what we're looking at here is 2 triangles. Triangle 1 has a base of 2 and a height of 4. Triangle 2 has a base of 1 and a height of 2. So the answer to this one is going to be, for the left-hand one, for this one here, the red one, is going to be 1/2 times 2 times 4. And to that we're going to add the green one, which is going to be plus 1/2 times 1 times 2. So altogether we're going to get 1 times 4 is 4, 1 times 1 is 1, 4 plus 1 is 5. So all three of those evaluating in terms of area, there's going to be either a trapezoid or a triangle in the first one, there's going to be a quarter or a half circle above a rectangle of some sort in the second one. There'll be an absolute value expression, so chances are 2 triangles. Just know your area formulas and be ready to use those. Okay, from this point forward, we're just evaluating integrals. If it's a definite integral, I expect a numerical answer. I don't remember if there's any indefinite integrals. If we hit that, we'll deal with that when we get to it. The first few are going to be just basic ones, polynomial function structures, or things that can be made to look like polynomials. The antiderivative of a polynomial is just going to be raise the power by 1 and divide by the new power. Raise the power by 1, divide by the new power. Once you've found the antiderivative, once you've done the calculus, then get rid of the symbol for integration, get rid of the dx, and rewrite it like so. I would simplify first. This just happens to divide, so I get x cubed plus, and that also divides x squared. And once you get to that point, substitute 2 first. 2 cubed is 8. 2 squared is 4. And then substitute 0 and subtract. 0 cubed is 0. 0 squared is 0. 8 plus 4 is 12. Minus 0 makes 12. Number 7, again, a polynomial function. So, the antiderivative of 2 is 2x. Any constant, just put an x on it. Antiderivative of x to the 7th is x to the 8th divided by 8. I've done my calculus, so I'm done integrating. Integral symbol disappears, dx disappears, 0, 1 go over here. Substitute 1 first, 2 times 1 is 2. 1 to the 8th is 1 over 8 is 1/8. Substitute 0, 2 times 0 is 0, 0 to the 8 over 8 is 0. 2 minus 1/8, that's 16/8 minus 1/8 is 15/8. Minus 0, so 15/8 is the answer to that one. Number 8 is not already in polynomial structure. It's also not going to be simply done using the substitution technique we just recently did. The better plan here is change that to x to the half power times x minus 2 dx. I haven't done any calculus yet, so it's still an integral, so its dx is still there, the integral symbol is still there. This is algebra. A quick little distributive property here, still algebra. So I haven't done any calculus yet, although calculus symbolism is still there. X to the half times x is x to the 3 halves. X to the 1 half times negative 2 is negative 2x to the 1 half dx. Now, x to a power, it's ready to integrate. It's just power function. So x to the 5 halves divided by 5 halves, better known as times 2/5, minus x to the 3 halves, 2x to the 3 halves, divided by 3 halves, which is the same as times 2/3. I've done the calculus, so now the integral symbol disappears, dx disappears. I put this bracket, put the 4 and the 9 up here. I can make it a little prettier before I substitute. So 2x to the 5 halves over 5 minus 4x to the 3 halves over 3 from 4 to 9. We substitute the 9 first. Now, when you see a half power, that means take a square root, and then the top of the power means to raise it to that power. So the square root of 9 is 3. 3 to the 5th power is 243 times 2 is 486. The square root of 9 is 3. 3 to the 3rd power is 27. 27 times 4 is 108. Seems right. All right. So 486 fifths minus 108 thirds. Now if I substitute 4 in, the square root of 4 is 2. 2 to the 5th is 32 times 2 is 64. And the square root of 4 is 2. 2 cubed is 8. 8 times 4 is 32. Now you may have noticed that 108 divides by 3 but 32 doesn't, so there's no way to get rid of the 3 altogether, so just leaving it over 3 is fine. At this point I've just got a bunch of fractions with 5 and 3 in the denominator, so if I get a common denominator going on here. 15. 486 times 3 is 1458, I hope. Doubting myself now. 486 times 3 is 1458, good. 1458. 108 times 5 is minus 540. 64 times 3 is minus, is going to be 2 carry the 1, 192. And positive 32 times 3 is going to be plus 96. So 1458 plus 96 minus 540 minus 192. Just to save time, I'm going to throw up the calculator. 1458 minus 540 minus 192. I hope it was plus 96. Comes out to 822. And 822 fifteenths. Only 3 and 5 go into this. 8 and 2 is 10 and 2 is 3, so 3 goes into that, or 12, so 3 goes into that. So I reduce by 3. Let's see, it'd be 274 over 5 would be the right answer to that problem. I don't know if I'll make the one on the test more pleasant than that or not. Maybe I will. But anyway, that's how you do it. Number 9. This one is all ready to go with the Usubstitution technique. I would probably do that. But just know that we have the option on this one, since it's just a small power like 2. I'm not going to do it this way, but I just want to show you this is possible for this specific one. 4 plus 2x to the 4th, sorry, 4x to the 4th, plus x to the 8th. So I just square that, square the first, double the product, square the second, and then distribute the 4x cubed through. I get 16x cubed plus 16x to the 7th plus 4x to the 11th. Okay. And now it's a polynomial function. We can do it that way. I would prefer to do this with Usubstitution because there's no guarantees the power on the test will be 2. Maybe it'll be 17 here. I don't know. It might be something ridiculous there. So if I'm going to use Usubstitution, it looks like this. I see it's a power structure. Again, when I'm using Usubstitution, I don't look at the whole problem. I look at the piece of the problem that looks like it's one of those nice structures I know how to integrate. And I make the argument of that structure U. So U is going to equal 2 plus x to the 4th. du is going to be the derivative, which is 4x cubed dx. We do the differential. And if you notice, 4x cubed dx is right there. So there's du. And this is u, which is right here, which is squared. So I'm going to change the integral from what it was into u to the 2nd power du. So going from what it was to a much simpler structure. And then I'm going to change my interval from this is dx, so this is all about x. That's x equals 0, that's x equals 3. This is du, so I want both of these to be u's. So I take the x equals 0 and I put it into here. 2 plus 0 to the 4th is 2. I take my x equals 3, put it into here. 3 to the 4th is 81 plus 2 is 83. And now that problem doesn't exist anymore. This is the problem. And this is much easier to do. U squared du. The antiderivative of u squared is u cubed over 3. Okay, haven't done calculus yet. I've just done some substitution. That's really some algebra stuff going on there. Once I've done the calculus doing an antiderivative, now I get rid of the du and I put my interval down here. The answer is going to be 83 cubed over 3 minus 2 cubed over 3. 83 to the third power is 571,787. Minus 8 all over 3. Minus 8 divided by 3. And it divides even less. So 190,593. If that didn't divide evenly by 3, it would be this over 3. Just you can write it at that point, but I'd go ahead and try it out. Maybe it works. So again, that's how I would go about doing it. But again, if you square the binomial, distribute the thing, you get a power structure. You can always do a power rule for each term. I don't want to have to deal with all those 11 powers and stuff I saw. So that looks like it's a little more friendly. Moving on to number 10. Now we're into Usubstitution outright. What I'm looking at here, anytime you see a power structure on the bottom, it's going to be Usubstitution every time at this point in our calculus careers. So I would probably rewrite this as x to the 5th, parentheses, 1 plus x to the 6th to the negative third power dx. Just to create that nice power structure, something to a power with other stuff dx. Okay? Don't focus on anything but the power structure. Whatever's being raised to the power is u. So u equals 1 plus x to the 6th. Du is the differential, which will be 6x to the 5th dx. Compare what we have to what we need. I'm supposed to have 6x to the 5th dx. I've got x to the 5th dx. I'm missing the 6. So I need a 6, I put a 6. If I put a 6, I'm going to put a 1/6. Okay. Anything you put in, you have to put its reciprocal out. So all this stuff here underlined in green is du. This is u. Alright, so the problem becomes 1/6 outside, integral. This is u to the negative third power, and this is du. And this is an indefinite integral. All that means is plus c is part of the answer. With the definite integral, we get those numerical answers. Indefinites, we got to go ahead and just get a something plus c. So if I go on to solve this, the antiderivative of u to the negative third power is u to the negative second power over negative 2. Which is being multiplied by the 1/6 that's outside, and there's officially a plus c. And the plus c is kind of just off to the side, so maybe I'll just leave it out of the bracket there just to make it a little simpler to deal with. Plus c is just part of the answer. It doesn't matter if it's inside, outside, whatever. This is what's going to be fixed, and then the plus c is just part of the answer. If I beautify this up a little bit, negative because opposite signs. 1 belongs on top, 12u squared on the bottom. And the final thing to do, this is a dx problem, this is a u answer. I need to get it back in terms of x. I go back and substitute u back in. U is 1 plus x to the 6th. So negative 1 over 12 parentheses 1 plus x to the 6th squared plus c. U is being squared, so Usubstitution is being squared. That would be the best answer. That's what I expect to see on your paper. Do not forget the plus c. It's a -1. Each problem is worth 8 points. It's 1 point you don't need to lose. So don't forget about your plus c's on your indefinite integrals. Number 11, once again, indefinite integral here, so another plus c, another chance to lose a point, so be careful. Trig functions, you got your 6 trig functions: cosine, sine, secant squared, cosecant squared, secant tangent, cosecant, cotangent. Any one of those 6 structures expect to be a trig derivative, or antiderivative. Cosine of whatever. The whatever is going to be u. So u is equal to 5x. So du is going to be its derivative, which is 5, and then dx. So looking at my integral here, I got my cosine of 5x dx. The du is 5 dx. dx is there, but 5 isn't. So I'm going to put a 5 in. Put a 5 in, I got to put a 1/5 out. U is equal to 5x. U is right there. So this is cosine of u. This is du. So I've got my new integral. So 1/5 integral symbol. This is cosine of u. And 5 dx is du. So just again, I've substituted. I've made it into a simpler antiderivative. This is very simple to do. Antiderivative of cosine is sine. Sine is not a cofunction, so it stays the same sign. Positive stays positive. Times 1/5 plus c. So the 1/5 gets multiplied by the antiderivative, so sine u over 5. And again, the problem says to evaluate, it says dx. This is u, it's not x. So the final thing is to put u back in. So the final answer is going to be sine, parentheses, 5x over 5 plus c. Again, plus c being left off as a -1 automatically. So be careful you don't forget to do that. And our last problem. This is going to be the complicated Usubstitution. It's not going to work out as prettily as the other ones are. Once again, indefinite integral, so another plus c happening here, so be careful. That's 3 in a row. Again, I got a power structure on the bottom. I'm going to expect Usubstitution right off the bat. X cubed plus 5 to the -3rd power dx. So if I come over here and do my Usubstitution stuff like I normally do, I'm going to let u equal whatever stuff's inside the parentheses there. So x cubed plus 5. Then I go ahead and do du, which is 3x squared dx. And what I'm looking at here is this is not x squared, it's x to the 5th, so the powers don't match up. So that's a problem. That's a bigger problem than the other two issues were. So the last two were fixed with a constant. So multiplication by a number fixed it. When you have to multiply by a letter, it makes it much more complicated. So what I'm going to do is I'm going to split this apart a little bit to get some pieces in there. So I'm going to make this x to the 5th power into x to the 3rd power times x squared. I'm going to keep this x cubed plus 5 to the -3rd power, and I'm going to keep that dx. So just so I can say an x squared, so I can kind of work along with this. So looking at what we have, u is x cubed plus 5. There's u. du is 3x squared dx. If I put a 3 here and a 1/3 out there, 3x squared dx is du. So all that's good, but I got this x cubed hanging out here. All right, so looking at u equals x cubed plus 5, u minus 5 is equal to x cubed. Okay, that's just basic algebra. Move the 5 over. That's from this expression. It's got to be from this expression. But just do a little algebra and figure out what x equals. Usually we find out what x is, but that says x cubed equals, and that's exactly what we need to know. So x cubed equals u minus 5, and x cubed is right there. So every piece of this can be changed to something about u. This can be changed to u minus 5. This can be changed to du. This can be changed to u to the -3rd power. So all of a sudden it's going to be a u integral. So if I substitute all my stuff in, 1/3 is necessary. This is u to the -3rd power. This part here. This is u minus 5. I'm replacing one object x cubed with two objects u minus 5, so I'm going to use parentheses. And 3x squared dx is du. And just like that, I went from this problem into this problem. And everything is simpler because now, if a simple distributive property gets me into a polynomial structure. U to the -2nd minus 5u to the -3rd du. So, what's left to do now is to integrate this thing. So, I'm doing calculus. So, u to the -1st over -1 minus 5u to the -2nd over -2 plus my constant. If I beautify this up, make it look a little nicer, this is -1 over u. This is going to be plus 5 over 2u squared. Distribute the 1/3 through, I get -1 over 3u plus 5 over 6u squared plus c. Once I get the answer in terms of u in simplest form, then again, it's dx. I want to get x as my answer. I'm going to change u back to x cubed plus 5. So my final step here is going to be to change these u's into x cubed plus 5. So negative 1 over 3 times x cubed plus 5 plus 5 over 6 times x cubed plus 5 squared plus c. That's the right answer. If I wanted to go one extra step, if I really wanted to impress my teacher, maybe I get a common denominator out of this. So, for example, if I've made this x cubed plus 5 squared, put an x cubed plus 5 on top, and that's 3, I need it to be 6, so times 2 times 2. That would be negative 2x cubed minus 10 plus 5 all over 6 times x cubed plus 5 squared plus c. And finally, if I combine like terms, negative 2x cubed minus 5 over 6 times x cubed plus 5 squared plus c. I am completely fine with the black answer here, leave the purple out. That would be fine, but again, the chances are if you have that structure, you can break it down into just a simple structure like that, stuff over stuff plus c. Again, I wouldn't count this wrong. That just shows me that you wanted to go a little further. Put that on your test if you wanted to triangle a little further. You know, go ahead, but just make sure the correct answer is on your test in case you happen to mess up along the way there. A little bit of algebra, but it's not very pleasant algebra, so